Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about ergodic random process example. The example is a random process is defined as x of t is equal a cos of omega ct plus theta, where theta is a uniform random variable over 0, 2 pi. Verify that the process is ergodic in the mean sense and autocorrelation sense. Coming to the solution, given that the random process x of t is a cos of omega ct plus theta. So now here omega c is a constant and theta is a uniform random variable over 0, 2 pi. So using the standard expression of the probability density function of the random variable x, that is 1 by b minus a over x is equal to a to b. So using the standard expression, now here theta is a uniform random variable. The probability density function of random variable theta is f of theta is equal 1 by 2 pi minus 0 is 1 by 2 pi for 0, 2 pi. The statistical mean average is expectation of x of t. So now here x of t is a cos of omega ct plus theta. The expectation of x of t is equal a cos of omega ct plus theta. So now here a and omega c are the constant. Theta is a uniform random variable. So using expression of the expectation of x of t, given that the range of the theta is 0 to 2 pi, so expectation of the function is integral 0 to 2 pi a cos of omega ct plus theta into probability density function of the random variable theta, that is 1 by 2 pi into d theta. So a by 2 pi is constant, that is written before integration. Integral cos is sine of omega ct plus theta over 0 to 2 pi. Now substitute upper value of theta and lower value of theta. We get sine of omega ct plus 2 pi minus sine of omega ct plus 0. Sine of 2 pi plus omega ct is sine omega ct, and plus sine omega ct minus sine omega ct is cancelled. Within the bracket term is 0. A by 2 pi into 0 is 0. So therefore expectation of x of t is equal to 0. So now here the mean of the random process is independent of time, that is constant, and this is a statistical mean function. Next, find out the time average mean function. So we know that the time averaging mean function is time average of x of t or x of t bar is equal limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x of t dt. So given that the random process x of t is a cos of omega ct plus theta dt. So now here substitute the tau value, tau tends to infinity. So 1 by t is equal to infinity. 1 by infinity 0, 0 into something 0. So therefore the time averaging mean function is 0. So therefore the statistical mean function is equal to time averaging mean function. So now here the condition is satisfied. The statistical average is equal to, hence statistical averages is equal to time averages in mean case. Hence the random process is ergodic in the mean sense. Next, find out statistical autocorrelation function. So we know that the statistical autocorrelation function is Rxx of tau is equal to expectation of x of t into x of t plus tau. Given that x of t is a cos of omega ct plus theta, and given random process x of t is substituted by t plus tau, we get x of t plus tau. X of t plus tau is a cos of omega ct plus omega tau plus theta. So a into a square is written before expectation. The within the bracket term is 2 cos a cos b. So now here in the numerator 2 is the missing, multiplying numerator and denominator by 2, we get a square by 2 into expectation of within the bracket term is cos of a plus b plus cos of a minus b. So this is the a term and this is the b term. So cos of a plus b is cos of 2 omega ct plus omega c tau plus 2 theta plus cos of a minus b is here cos of omega c tau. So using expectation expression, the expectation of the first term is integral 0 to 2 pi cos of 2 omega ct plus omega c tau plus 2 theta into density function of the theta is 1 by 2 pi d theta plus expectation of the second function is integral 0 to 2 pi cos of omega c tau into density function of the theta is 1 by 2 pi into d theta. So that is equal 1 by 2 pi is constant, that is written before integration. Here also second term integrating with respect to theta cos omega c tau by 2 pi is constant, that is written before integration. And this first term is the first term of the integration already explained in my previous problems of random process, autocorrelation function of the random process. The first integral term is 0 and the second integral term is integral 1 d theta is theta over 0 to 2 pi. So after substituting upper value of theta and lower value of the theta 2 pi minus 0 2 pi, numerator and denominator 2 pi is the cancel. The final resultant value of the autocorrelation function is Rxx of tau is equal to a square by 2 into cos of omega c tau. So now here the autocorrelation function depends on tau, and this is the ensemble average or statistical average of the autocorrelation function. Next, find out the time averaging autocorrelation function. So we know that the time averaging autocorrelation function is limit tau tends to infinity 1 by t integral minus t by 2 to t by 2 x of t into x of t plus tau dt. And substitute x of t value, x of t is a cos of omega ct plus theta and x of t plus tau is a cos of omega ct plus omega tau plus theta into d theta dt. A into a square, that is written before integration, and uh, uh, cos of omega ct plus theta cos of omega ct plus omega c tau plus theta is the cos of a plus b plus cos of a minus b by 2. So that is, and this omega ct omega c tau plus theta is the a value, omega ct plus theta is the b value, cos of a plus b is cos of 2 omega ct plus omega c tau plus 2 theta plus cos of a minus b is cos of omega c tau by 2. So that is equal limit tau tends to infinity a square by 2t into integral minus t by 2 to t by 2 cos of 2 omega ct plus omega c tau plus 2 theta into dt plus integral minus t by 2 to t by 2 cos of omega c tau dt. And in the first integral term, integral cos is sine of 2 omega ct plus omega c tau plus 2 theta. Now with integrating with respect to t divided by 2 omega c over minus t by 2 to t by 2 plus now with integrating with respect to t cos omega c tau is constant, that is written before integration. Integral 1 dt is t over minus t by 2 to t by 2. So now here substitute in the first term, substitute upper value of t and lower value of the t. Finally we get the first term is 0 and plus second term is substitute upper value of t and lower value of t, we get t by 2 minus of t by 2 is t. So numerator and denominator here t is the cancel. Okay. So the second term is cos of omega c tau into t. Therefore the time averaging autocorrelation function is, so now we are multiplying a square by 2t within the bracket 0 plus omega c tau t is omega c tau into t. So numerator and denominator capital T is the cancel. The remaining RHS term is a limit tau tends to infinity a square by 2 cos of omega c tau. So now here there is no t term and applying the t tends to infinity we get the time averaging autocorrelation function is a square by 2 cos of omega c tau. So the statistical average autocorrelation function is a square by 2 cos of omega c tau, and time averaging autocorrelation function is also we are getting, we got a square by 2 cos of omega c tau. So both are same. So therefore the time average autocorrelation function is equal to statistical average autocorrelation function. Hence the process is ergodic in the autocorrelation sense. Thus, the ensemble averages and the time averages are equal in the mean and the autocorrelation function set. Hence, the given random process is an ergodic random process. So, this is the procedure we can determine, we can check it, the given random process is ergodic random process or not. Now, here the given example is ergodic random process.